All right, so this is the Quantish Prediction Relay. I'm Bosch from Quantish, and we are building privacy solutions for prediction markets. Quantish focuses on building AI agents for prediction markets and aggregating all of the markets in one place from multiple platforms. So we are trying to be in the running for a few different things here, definitely building with privacy cache. Another one is we're using Arcium's encryption system that is currently on DevNet, so not in the full flow yet, but we have the program deployed and everything working properly on DevNet. And then ZK Noir, definitely using for our ZK proof in our relayer system, and this is RPCs for all of this. And yeah, so okay, so that's enough about that. And then the actual system here. So basically what it is it's a relayer that takes orders on these markets. Ideally, many people are using this at one time. It batches the orders together, executes them, and uses a system of ephemeral wallets as well as privacy cache to obfuscate the first wallet that holds the USDC that wants to place the order through to the final ephemeral wallets, which are different from the user's first initial wallet. So it's a multi-layer system, and I'll get into it right now. So the first thing to do here is create a few ephemeral wallets. So I have three ephemeral wallets set up. The first wallet is basically going to be the wallet that does the execution with this relayer system. So the first layer of obfuscation is moving money from here into this first wallet to interact with our relayer. And then what we can do is also designate the output of the positions that we're putting the orders in through to be output to two other or more ephemeral wallets that they'll end up in finally. So basically, instead of the relayer collecting all of the information about the orders through this plain text memo, when Arcium is live on mainnet, and right now we currently have a program deployed to DevNet, properly tested and everything, what this would essentially do is it would encrypt this information and pass it through to Arcium's MPC, and it would aggregate essentially from Arcium and then process through the relayer to keep the USDC amount and the position size and the wallets as well for the users hidden when processing that. So here's a little bit of a demo of what the here's a little bit of a demo of what the encryption would look like, just the encrypted blob that we would be passing when Arcium is live. And this is essentially something that we've done on DevNet already, of course, on Arcium. So what it can see is the market and the side, but what is hidden is the wallet that it's being output to, as well as the USDC value of that trade. So the last step of this whole system is that the relayer, whenever it executes this batch of orders, it always generates a ZK Noir proof that because our system will be open source on GitHub, anyone could basically take these proofs and run them to make sure that they were accurate, to make sure that the relayer did indeed execute what should have been promised in that batch. And we are using Aztec and their Noir language for building on ZK. Easy. So let me just go through this real quick. We'll do wallet 2 and 3. We'll buy on the yes side, put in the order, and we have it automatically computes the amount of balance that will be needed to execute all these transactions. So it really only makes sense to do this if you're placing a larger amount of orders because you are burning through some Solana. But this will get everything moved through the ephemeral wallets and then also cover the gas through the relayer as well. So let's put this through the gas through the relayer as well. So let's put this through. All right, so it's moving through privacy cache, executing. All right, cool. So we got the order submitted. We put in the order for $2. We got 2.94 shares. So in the end here, we can see that we have one holding in wallet 2, and actually none hit the ephemeral wallet 3. Now this is because of DFlow and the Calshi system, and because it doesn't always fill all of your shares at one time. And then yeah, so naturally there's some things that we can't escape just because it's also early in the DFlow API system. But we can see that it did successfully pass this amount here from the order. It basically was only able to fill half a share, but it did get received in this ephemeral wallet here. So ideally an individual wallet. So this is our submission for the Solana Privacy Hackathon. I'm going to go figure out how to edit this into 4 minutes, and we really appreciate you checking this out. Thank you.